Welcome to my channel, guys. This is Anjo, aka Code and Travel. This video series is going to give you exactly everything you need to know to be a Java developer or programmer. We are going to start from the basics and take it step by step to reach a pro level by the end of this series. Look forward to building your own Java applications from start to finish. Hit like and subscribe to keep you updated on the future updates regarding this series. Without further ado, let's start. Let's go directly to our introduction to Java. So what is Java? I'll spare you guys from all of these scraps going on in my slides, but remember that Java was developed by James Gosling and is now one of the most used programming languages in the world. Java is a programming language expressly designed for use in the distributed environment of the internet. It was designed to have this look and feel of the C++ programming language if you have encountered C++ programming language in the past. But this is simpler to use than C++ and enforces an object-oriented programming model. So what is Java used for? It is used for 1. Mobile applications. So when you open your Android phone or any app, actually even your iOS phones, they are actually written in Java programming language. With Google's Android API, which is similar to our Java's JDK. This Java JDK, we'll discuss this later on so that you'll understand, okay? Desktop applications, web applications. When you open your browser and browse some sites mostly on the government, you can see a lot of healthcare, insurance, education, defense, and several other departments have their web application built in Java. Next, web servers and application servers. So Java is mostly used to write a server-side application, mostly without any front end, which receives the data from one server, processes it, and sends it to the other processes downstream. But for now, you don't have to remember this, guys, okay? Next is games. Database connections, just like JDBC, ODBC, SQL or NoSQL, and much more. So why do we use Java? Java works on different platforms. Java is one of those cross-platform or platform-independent languages. You can write a Java code from one operating system and you can use it to run on other operating systems. It is one of the most popular programming language in the world. It is easy to learn and simple to use. It is open source and free. So you can just go over the internet and Google the Java installer, install it, and you're good to go. It is secure, fast, and powerful. The main reason for this is because of the Java's JVM, which stands for Java Virtual Machine. It allows Java programs to run on any device or operating system. This is known as the write once and run anywhere principle. And it manages also the optimization of the program memory. So it is secure because instead of running from a physical machine, which may encounter issues, you are actually running from a virtual machine where tampering or changing what's going on in your application is hard to do. It is fast because instead of you or your program allocating the memory, the JVM manages and optimizes the program memory itself. Next, it has huge support. It has huge community support. Programmers, this is not a secret, you know. Programmers are running to Google or Stack Overflow most of the time, right? Kidding aside, you'll find more support from peers in Java than other programming languages. Java is an object-oriented language, which makes it easier to write codes because you can make your code modular and reusable. So you don't have to write one type of code for a certain process over and over. All you need to do is call it out and you can incorporate it to other processes. Let us now dive a bit deeper on what object-oriented programming is. Object-oriented programming, or the OOP, is a programming paradigm which relies on the concept of classes and objects. So there are many other object-oriented programming languages. This includes the JavaScript, the C++, and even the Python one. OOP concepts in Java are the main ideas behind Java's object-oriented programming. These are called abstraction, encapsulation, inheritance, and polymorphism. So grasping this object-oriented programming concept in Java is the key to understand how Java works. Abstraction means using simple things to represent complexity. We all know how to turn the TV on, right? But we don't need to know how it works in order to enjoy it. So in Java, abstraction means simple things like objects, classes, and variables represent more complex underlying code and data. This is important because it lets you avoid repeating the same work multiple times. Next is encapsulation. This is a protective barrier that keeps the data and code safe within the class itself. This way we can reuse objects like code, components, or variables without allowing open access to the data system-wide. Inheritance. This is a special feature of the OOP in Java. It lets programmers create new classes that share some of the attributes of existing classes. So this lets us build on previous work without reinventing the whole wheel, or meaning we don't have to start from scratch. Polymorphism. This Java OOP concept lets programmers use the same word to mean different things in different contexts. So we use the parent-child relationship to make processes easier in Java. We are going to dive deeper into these concepts on the following videos, so make sure to click that subscribe button, guys. So earlier, we've talked about Java being a platform-independent language. I know this might be quite an overwhelming diagram for you guys, but please bear with me and we'll discuss this one by one. When you write a program in Java, what you're writing is what's known as the source code. This source code can be saved using the .java file extension. So you can see here, anything with .java extension is your source code. This source code can be compiled using what's known as the bytecode with a .class extension now. This bytecode is the machine language that all of these operating systems can understand. So you don't necessarily have to know how to read this bytecode, since everything is being taken care of in the background. For example, you have written your code in a Windows operating system. As long as it is compiled and converted into a bytecode, you can run this on different operating systems like Mac and Linux. I know this may seem magical to you guys at first, but all of these processes are being taken care of what's known as our JDK and JRE. But again, what is this JDK and JRE? JDK, or the Java Development Kit, it allows developers to create Java programs that can be executed and run by the JVM and the JRE. So the Java Development Kit, or JDK, is one of the 3 core technology packages used in Java programming, along with the JVM and the JRE. The Java Runtime Environment, or the JRE, is a software layer that runs on top of a computer's operating system and provides classes or class libraries and other resources that a specific Java program needs to run. The JDK and the JRE interact with one another to create a sustainable runtime environment that enables the seamless execution of Java-based applications in virtually any operating system. So the following make up the JRE runtime architecture. First, we have here the class loader. The Java class loader dynamically loads all classes necessary to run a Java program. Since Java classes are only loaded into the memory when they're required, the JRE uses class loaders to automate this process on demand. We also have here the bytecode verifier. This ensures the format and the accuracy of the Java code before it passes to the interpreter. So in the event that the code violates system integrity or access rights, the class will be considered corrupted and won't be loaded by the bytecode verifier. Lastly, we have the interpreter. So after the bytecode successfully loads, the Java interpreter creates an instance of the JVM that allows the Java program to be executed natively on the underlying machine. So to give more context to what we are talking about, let us open our browser and type in Java, just like that. When you open the very first item, this one, this is the JRE. So this page shows you the JRE. So you need to download this one if you want to run a Java program in your computer. So this provides the runtime environment on your device. Next, if you try to search for a JDK, now this is what it will show you. It will bring you to the Oracle site where you can download the JDK. When you downloaded the JDK, you don't need to download the JRE separately, guys, since it is already included on the JDK. This JDK is what you use when you want to develop a Java program from scratch. So that is mostly what you needed to have a jump start with Java programming. I will include all of the links in the description. In our next video tutorial, we're going to try and install our JDK and run our very first Java program. So please remember to click like and hit on that subscribe button to keep you posted on the updates. Thank you guys and see you on the next one.